In the last video, we covered the scan function and talked about how it is a very efficient way to iterate over arrays in JAX. But JAX also offers other ways to work with loops, and those are the while and for loops. And you can use both the built-in Python while and for loops, but JAX also offers you their own versions that come with some advantages as well as some disadvantages. So we will start with the while loop. And if we have a look at the documentation, we can see that the while loop expects a condition function, a body function, as well as some initial value. And from the documentation, you will see that the JAX while loop is equivalent to this function. And as you can see, both the condition function as well as the body function get the same value as input, and the body function is the one that updates the value. So here we have a very simple example of exactly that. We have a simple condition function that gets I as input and simply returns true if I is less than 10, otherwise it will return false. And our body function gets the same I as input and simply increments it by 1. And here in our call, we pass both the condition function and the body function as input, as well as the initial value, which is 0 in this case. If we run that code, we can see that the output is 10, as well as the JAX expression of our while loop. And as you can see, we have here our while primitive and the body and condition JAX expressions. I've also gone ahead and wrote the Python version of the same thing, because you can actually use the built-in Python while keyword. And here you can see the JAX expression. It is much longer than the JAX version of the while loop, and the longer this while loop becomes, the longer it will take to compile your function. So the while version from JAX is much faster in that regard, but it comes with some important downsides. For one, if you have a look at this function right here, it's not known at compile time how long this while loop will be. And because of that, the JAX while version does not support automatic differentiation, which you can verify here in the documentation, where it says that reverse mode differentiation is not supported because XLA requires static bounds. So this is very important to keep in mind, that when you use this while loop, you cannot use reverse mode differentiation, which is to say that the automatic differentiation, that is the grad function, won't work when you use this while loop. On the other hand, we have here the for loop from JAX, and it works kind of the same way as a normal Python for loop. Here you have to define the lower and the upper bounds, as well as pass it some body function and the initial value. Here in the documentation, we can see the equivalent Python version of the JAX for loop. Our body function gets this time two inputs, which is I being the current index of the loop, as well as the value, and it returns the updated value. This means that our body function here gets I, which is the current index, as input, and the value, and it simply increments the value by 1. We can once again print the output of this operation, which should be 10, as well as have a look at the JAX expression of this for loop. Once again, the output is 10, but this time in the JAX expression, we can see a familiar face, which is the scan function. So the thing is with the for loop that if you pass it static bounds, for example, in the form of Python integers, like we did right here, and not some traced JAX arrays, then the compiler is able to express this for loop in terms of a scan function. This means that the for loop version is in fact reverse mode differentiable, while the while version is not. On the other hand, if these values are dynamic, then the for loop will be expressed as a JAX while primitive, which means that automatic differentiation won't work. So that was it for this video. To quickly summarize, JAX offers you two more ways to interact with loops, which are the while and for loops. And the while loop, because it is dynamic, does not support automatic differentiation, while the for loop does support it if the lower and upper bounds are, for example, Python integers, because then it will be represented as a scan function in the JAX expression. So I really hope you enjoyed this video and will stick around for more. Thanks for watching, and I will see you in the next one.